Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Green Tech Today is provided by Cachefly at CACHEFLY.com.
I'm Becky Worley, and this is the Twit Network's Top 25 Green Tech Innovators Series.
This episode of Green Tech Today is brought to you by the Ecomagination Challenge from GE. GE and its partners are awarding $200 million to ideas that help build the next generation power grid for the 21st century. For more information and to view and comment on ideas, go to ecomagination.com/challenge. And by Squarespace.com, the fast and easy way to publish a high-quality website or blog. For a free trial and 10% off the lifetime of your new account, go to squarespace.com and use the offer code GTT. In the year 2020, there will be approximately 1.2 billion vehicles in use around the world. And according to J.D. Powers, hybrid and electric vehicle sales will take up only 7.3% of the market. That's hardly a scratch in the surface of the automotive industry, but across the board, manufacturers are beginning to roll out their electrical offerings. GM, the creator and killer of the EV1, is trying again with a new extended-range electric vehicle called the Chevy Volt. There are substantial challenges to achieving mainstream adoption of electric vehicles, but with innovations in vehicle technology and development of electrical infrastructure, GM and the Volt might have a chance at success this time around. Hi, I'm Dr. Kiki. I'm in LA checking out GM's Chevy Volt. We're going to take a test drive. I'm going to find out what's under the hood, and we're going to talk a little bit about how GM is innovating with the government. I'm here with Sam Abuelsamid. He's going to show me the car. Yes?
Yes, absolutely.
Great. As a driver, somebody who might want to purchase this, what are some features of the car that I want to be familiar with?
Well, the Volt is an extended range electric vehicle with plugs in. You can get 25 to 50 miles of electric driving range, purely electric, no emissions directly from the car, and you can charge it up whenever you can get a plug. Once the battery runs down, the beauty of it is you can keep on going. You're not limited to when the battery gets depleted. Once with the battery depleted, you can go on for another over 300 miles and get up to 350 or so miles of total range. And you can take it and drive it just like any other car.
All right, so take me on a tour. What do we have in the car? Show me the features.
Okay.
Trunk size, what's under the hood, how do I charge it?
All right, well, the Volt is a four-door compact hatchback, roughly the size of a Chevy Cruze. Got the trunk here, lots of cargo space in the back.
Yeah, lots of space.
Seating for four passengers inside here. You got your your extension cord here, so you can plug it in anywhere. Even if you don't have a 240 volt charger, you can still plug it into a standard outlet. The Volt will charge completely overnight in about 10 to 12 hours, or if you have a 240 volt charger, about 3 to 4 hours.
Is there room for a spare tire in here?
No, no spare tire, but you do get an inflator with sealant, so if you have a problem, just do that and it'll seal it right up.
Okay, let's move on to the front. Let's take a look at the. We've got what looks like a gas tank here.
That is, in fact, the gas tank. So you fill that up with gas, and once your battery is depleted, if you need to keep going beyond that 25 to 50 miles, just keep right on going. Just seamlessly starts up the generator, and you're on your way.
Great. All right, so let's look around this way.
All right.
We head around the car. Nice room in the back seat.
Yep, got plenty of room for 2 adults in the back seat. The T-shaped battery pack runs down the middle of the car and then behind the back seats there. So it's a lithium-ion battery pack that keeps you going with no emissions.
Okay. What do we? Bing, bing. What do we have in the driver's area?
In the cockpit here, we have an innovative new interior with two 7-inch touchscreen LCDs for your gauges and your various controls. The center stack, you have your climate control, your entertainment system, your audio, navigation. It's all standard equipment on the Volt. And then you have a reconfigurable display for the gauges in front of the driver, so that it will tell when you're driving an electric, driving fully off the battery. It'll tell you your battery state of charge, how much farther you can go before the battery's depleted. Then it also has a special gauge with a little ball that goes up and down, tells you if you're driving most efficiently. You want to try and keep that in the middle of the range. If you go too high up or too low, then you're not driving it the most efficient mode. And then once the battery's depleted and the engine starts, the display automatically switches over, shows you your fuel gauge and how far you can keep going on gas before you run out.
Okay, can we take a look under the hood?
We can do that. Now this is the most unique part of the Volt, what we call the Voltec powertrain. And you got 110 kilowatt electric motor that provides your primary propulsion at all times. So it's always that motor is always driving the vehicle, no matter whether the battery is charged or not. Once the battery is depleted, then we also have a 1.4 liter gasoline engine, 4-cylinder engine, that drives a second motor generator that provides electricity to keep the car going until you run out of gas, basically. Then you just fill it up or plug it in and charge it again.
Right, so it's electric, the gas, it powers the generator to power the electric system. Okay, cool. Can I take it for a drive?
Absolutely.
Excellent.
Let's do it.
I'm going to take this for a spin in just a minute. When we come back, we're going to find out how this system works, what makes the electrical system in this car so special. This is Colin Summers. He is a member of the Customer Advisory Board, an owner of a Volt, and he's been driving one for about
a week.
A week, great. So how did you get on the Customer Advisory Board? Tell me about that.
I assume it was because I was an EV1 driver. We had an EV1 and then an EV1 Gen 2, and then GM took the EV1 cars away and crushed them, becoming the star of their own little documentary on who killed the electric car.
Yes.
And this was, I think, a way to sort of reach out to early adopters and people who are prime kind of target audience for the car, and see what we thought about the car, because we've had it, we'll have had it for a month or so before anyone else can have it in their garage at home, and so to give our feedback on it, if there's any sort of hiccups in the process of getting a charger installed or using the car day to day and stuff like that.
This is Mickey Bly, the Executive Director of Electrical Systems Engineering. Obviously, with the Chevy Volt, electrical systems are pretty important, right? So what are some of the biggest innovations that had to be made?
Obviously the biggest innovation was the battery. When we started 3.5 years ago in this program, we really didn't know how to do this, how to take a single battery that's used in cell phones or laptops and scale them up to the size needed to propel a vehicle like the Chevrolet Volt down the road up to 50 miles of range fully electrically, to go 100 miles an hour on electric range. So we worked very hard over the last 3.5 years working with key suppliers and in-house engineering to come up with that innovation. It was the biggest innovation on board.
So tell me about the batteries. What do we need to know about them?
Well, first of all, you don't need to know anything other than the fact that we've done all our homework, we've done the engineering. It is a very robust design. It's going to be warranted for 8 years, 100,000 miles. It's fully contained. All the safety engineering that's gone into it is a testament to the power, the horsepower, the engineering, the suppliers we put behind us along the way, and hopefully you never have to worry about it. It's there, and it's thought-free for you.
How long does it last on a charge? How long does it take to charge? What are those specific details?
Well, lasting as far as the life of the battery, we're warranting it up to 8 years, 100,000 miles. It will go much longer than that. We're very confident from the testing. Unfortunately, we haven't had 8 years of experience in the vehicle yet, so we're still, developing and doing that. As far as charging the vehicle, you can charge it two ways. You can charge it in a standard 120 volt system, and that takes about 8 to 10 hours to charge it, depending on how deep you've discharged it, and then up to full charge charge. If you have a 220 volt system in your garage where you can plug in with one of our charge cord sets, you can do it in 4 hours. I have one at home. I use it all the time. 4 hours, no problem. You go in, do some things, come back out fully charged, ready to go again. So it's really, it is a game changer. You're used to going to the gas pump in 3 or 4 minutes. You filled up the whole vehicle. You can't do that with electric vehicles, but with this vehicle, you can also have the gas side of the vehicle. Allows you to drive even beyond that 25 to 50 miles of pure electric range. You can drive over 350 miles along the way.
So you said the 8-year, 100,000-mile warranty. What kind of testing have you done to be confident that the batteries will last that long?
Well, obviously we haven't tested for 8 years along the way, and that's very important to understand that we've done a lot of simulation, modeling, testing. In fact, the very first battery we received, and I remember when it was October 31st, 2007 at 6 p.m. That battery is still on test today with no problem. So we've had real time, 3.5 years of testing on it. But the reality is we've done a lot of simulation modeling, a lot of advanced chemistry analysis on the parts. We're able to project that up over 15 years worth of what the impact is. We don't see any problems at all.
What is the chemistry of the battery?
It's a lithium-ion battery, and then that's got lots of formulations. The one that we're using here is called a manganese spinel. It's a patented technology that LG Chem, who is the leading in consumer electronics. You may even have an LG Chem cell in there, I'm not sure, in your iPad. Yeah. But they've led the way. They produce millions and millions of cells today for consumer electronics, and now we're bringing their technology, scaling it up, putting 288 of these cells together inside the vehicle. Simplicity. We've got lots of monitoring and control systems on board for it. Had great results.
In terms of the drive system, you said you have the electric propulsion, but you also have the gasoline-powered extended range. How does that work together?
Well, as we talked, you plug it in at night on the side of the vehicle. You have a little charge door right there. You plug it in, charge up to, in optimum conditions, up to 50 miles of electric range. You drive it, and if you drive further than 50 miles, then the engine, the gasoline engine that's underneath the hood, turns on. It's a generator, so it's just like if you have a backup generator at your house. It turns on automatically if the power goes out in your house. Well, this does a very similar type of thing. You don't have to get out, you don't have to turn anything over. Seamlessly. In fact, most people don't even know when it turns on, and it will start producing electricity. That electricity will allow you to continue driving down the road. You can go 300 more miles on a 9.5 gallon tank of fuel that's in the back. You literally can drive from Detroit or LA or wherever across the country. Joel Wanek just did that. He brought out in the car show here. He drove from Detroit to here. And there was no issues, no problems, didn't have to have range anxiety, any of those things.
And the gasoline engine with the generator to power the electrical propulsion, what kind of considerations and challenges were there in developing this system?
Well, what we tried to do with the engine side of the internal combustion engine is we wanted proven technology. We had enough to do on the rest of the vehicle to bring it to production. So we took our tried and true Family Zero engine, we call it in Europe, build millions of these engines already, and we picked that. It's a 1.4 liter normally aspirated engine, pure fuel injected, overhead valve, overhead cam engine, and it's been a great engine for us over there, very efficient. So when you are running on it, it's getting high efficiency from the fuel economy anyways. The challenges were getting it integrated, putting electric machines behind it, and then getting those control algorithms to the point where it was seamless. It was where the customer never knows, and that's our goal.
That's a good goal.
Yep.
For the accessories and the efficiency of the car, what kind of challenges were there in developing the entire electrical system for the car?
Yeah, one of the things is the car is an energy efficiency device. We wanted to make it to be the least parasitic. So if you look at the vehicle, beautiful aerodynamics on the vehicle, that's an efficiency way you can save the fuel. We've also looked inside the vehicle. My team has responsibility for all the electric systems. We have the state-of-the-art, lowest consuming infotainment system that's available out there. Very low energy consumption system, but it's a beautiful sounding car. So it has a Bose radio system in there, very low consumption, so it's efficient. Whatever you spend doing on the vehicle that's not driving sucks away from that battery. So the HVAC system, instead of normally heating the vehicle, heating the area up to keep you warm in the winter days, one of the things we did is we worked with an integrated system between the seat heaters and the actual air blowing across you. We found out that it's easier and more efficient to heat your body through the seat than blowing hot air across you to keep you more warm or warmer. So those are things we spent many, many hours in wind tunnels and cold testing to figure out how the most efficient way to do that is. So we wanted to be able to put as much technology on board, but really be considerate of the time. And we knew we had to bring this thing to market by the end of 2010. We're doing that, we've delivered on that. So we leverage as much of our global architecture, our global electrical systems, our radios, our infotainment, our clusters, as much as we could, but still put a lot of high-tech systems on board in the vehicle, like the battery, the propulsion system, the infotainment system, the heating system. All those things are very high-tech, but things you don't see and don't care about, we reuse as much as we could from other vehicles.
Yeah, can you compare this vehicle to, say, the Nissan Leaf or Toyota Prius? They're electric, the hybrid.
Yeah, well, it's different. It is a completely different vehicle. It's a completely different experience. The good news is all those vehicles are driving the momentum of customer demand around electrification. I'm not going to tell you one's better than the other. What I'm going to tell you that the Chevrolet Volt is clearly a vehicle that's different than anybody else's that's out there. It has the ability to be an electric vehicle. You never have to use a drop of gas if you're a shorter commuter, less than 50 miles a day or 50 miles a charge. But then you don't have any concern about long-term driving of the vehicle. You can drive down the road. You can go, as I said, all the way to LA if you want to. Most of the cars that are going to be electric vehicles can't do that, purely electric vehicles. As far as hybrids and plug-ins, different segments, we've defined a whole new category of propulsion, and that's what we're proud of.
And regenerative braking, how does that specifically work with this system?
Yep, like most hybrids, it has full blended regen braking. And what that is in fancy terms is if you don't have regen braking, when you want to stop, you use friction to grab the front brake systems and you actually waste all that as heat. Instead of allowing that to happen, we take the electric machine, the electric motors, and we reverse those and take that energy that would slow down the vehicle and push it back into the battery. So you can use it again. About 20% of the efficiency of any hybrid is from regen braking. We're actually pushing this up to almost 30 to 35% of its efficiency. So we really got aggressive and brought some really cutting edge technology to the vehicle.
Definitely. Your views, your opinion on where this is going. Are you optimistic about the future of electric vehicles in the United States?
Well, personally, I put my heart and soul into this project. I have responsibility for integrating all the electrical systems and all the General Motors products. This is clearly a future. It's going to be around the customer demand. I heard Joel mention earlier over 220 hand raisers, 220,000 hand raisers we've already had for the vehicle.
Yeah.
I am very optimistic about where electrification is going. Not necessarily because the customers are changing, the technology is changing. It's become affordable, it's becoming higher efficiency, and it's becoming to the point where you don't have to make any excuses. Get in the car and drive. Worry about the paint color, not what the battery technology is.
So the Chevy Volt is surely an innovative vehicle, but that's not the only place where GM is innovating. Coming up, we're going to talk about how GM plans to get energy into your car. And I get to go on a test drive.
We're partnering with 4 of the biggest venture capital firms in the clean energy space, 3 in the US, 1 in Europe. Again, we think that the combination of GE investment and venture capital investment is going to allow us to increase innovation. It's going to allow us to accelerate new ideas. It puts us shoulder to shoulder with some of the smartest tech investors, and we can use what I would call the industrial clout of GE to bring technologies to this marketplace faster.
GE announced its challenge at a San Francisco event along with its 4 venture capital partners. Emerald Technology Ventures, Foundation Capital, Kleiner Perkins Caulfield & Byers, and Rockport Capital Partners have all joined with GE. Ideas from companies and individuals can be entered through the Ecomagination.com website for the next 10 weeks. So check out Ecomagination.com.
Into the wall. Ooh, into the things. I don't get points for that, do I?
No, you get points for
running into things.
doing stunts and collecting coins.
I'm out of control. It's time to go for that ride that I've been so excited about. Ready?
Ready.
Okay. So, this key doesn't really do much in this car.
Nope.
It just unlocks the outside of the car in the possibility that the battery, everything's dead.
Yep. If the battery goes completely dead, you can still get into the car using the key, but that's about it. That's all you can do with it.
All right, dropping the key. So starting the car, what do I start with?
Put your foot on the brake pedal.
Got that.
Press the blue power button on the center stack.
Okay, do we have an emergency brake that I need to be aware of?
The parking brake switch is right here. It's an electric parking brake, but probably disabled right now, or off, and it's not engaged, so you're good. Just put it in drive, just like any other ordinary automatic transmission.
Okay. Got it in drive. We're now 0 miles an hour with a nice charge. I don't see anybody I'm going to run over. I'm going. Where should we go? So what is this showing me here right now?
Right now this is showing you that you've got electricity. Well, now you've got electricity flowing from the wheels through the motor back to the battery as you brake. That's regenerative braking. So the car uses a lot less of the regular friction brakes, the hydraulic brakes. It uses regenerative braking to slow the car down and recharge the battery.
Okay.
And now as you accelerate, you've got energy flowing from the battery to the motor and out to the wheels.
Interesting. And then what do I want to pay attention to in the dash?
On the dash,
I've got my speed. I obviously
Right.
don't want to be speeding.
Right. The gauge on the right-hand side there with the ball that's floating up and down is your efficiency gauge. So what you want to do is try and keep that as close to the center of the gauge as possible. That's your most efficient operating range.
Aha. Okay.
If you accelerate too fast, you'll see it go up. If you brake too hard, you'll see it go down. You're going. When you brake too hard, then you're going beyond what the regenerative braking can handle using the regular brakes.
Okay. And this tells me here I have 33 miles of electrical power left.
33 miles of electric driving range left.
And 248 of gas?
Yep. So you've got a total of about 280, about 285 miles or so you can drive. And what you'll see if you drive it for a while is that electric driving range can actually vary, and it'll depend. If you drive it gently, you'll see that it might actually start going back up again. If you drive it more aggressively, it'll drop faster.
That's interesting. So this will primarily use the electrical power before going to the gas.
Right. It always drives on electricity. No matter whether the engine's running or not, there's always electricity driving the vehicle. And unlike the hybrids that we're familiar with from other manufacturers, this one will always go to electricity first, as opposed to the others that start with the engine and use the electricity for boost.
Okay.
One of the things about the Volt is it's got several different driving modes that you can choose from. And using the drive mode button here, you can see in the instrument cluster there, it pulls up different modes that you can choose from. You get normal, sport, mountain, and eco mode. The normal mode is the one you typically use most of the time. Sport gives you a little quicker response when you press on the accelerator pedal, and tightens the steering up a little bit, so that gives you a little bit sportier feel. The mountain mode is an interesting one that we provided for times when, if you've got to be driving into the mountains, what it'll do is it'll actually maintain a higher minimum level of charge for the battery, because the battery doesn't get drained completely down and it doesn't get fully charged up in order to help it last longer. Because the lithium-ion battery here is designed to run for the entire life of the car, for 10 years or 150,000 miles. And so we don't completely discharge it, we don't overcharge it. The mountain mode will set that minimum charge level at about 45%, and what it'll do is allow you to have full power, full electrical power, if you have to climb a grade, an extended grade, driving through the Rockies or something like that.
Do you switch the drive? Can you switch it while you're driving, or do you?
Yep, you can switch it at any time. And then
try normal. And it just moves. Sport. Let's be sporty.
Right. And the other thing about the Volt, because it's electrically driven at all times, it actually will go up to its maximum speed of about 100 miles per hour on electricity.
Wow.
Whereas hybrids typically anywhere from 40 to 50 miles per hour Anything
Take
above
a right
that.
here?
Right, yes. Somewhere around 40 to 50 miles per hour, it'll stop driving on electricity and just drive on gas. Yeah, it does 0 to 60 in about 8.5 seconds.
Yeah, accelerated nicely. Aside from that air pressure whumping.
Completely silent.
Yeah, I think that's the... You just hear the other cars.
And even that, you don't hear much of what's going on outside. They did a lot of work on making the car as quiet as possible. Really take advantage of the electric drivetrain.
Energy info, just telling me how much
energy you're using, the energy efficiency. So this tells, based on your driving style and what you're doing right now. Climate setting, obviously the climate control's off right now, so it's 100% efficient. But your driving style, you're doing a little bit of checking out how quick it is, so you're only at about 33% right now.
I could be much more efficient.
Yes. And it'll also give you efficiency tips, but you don't want to look at those.
Read those while I'm driving.
Right.
Got it.
Those are for when you get home.
Yeah. How did I do? How can I do better?
If you primarily drive, less than 35, 40 miles a day, which is what 75 to 80% of all commuters do, you'll probably use almost no gasoline most of the time. You'll just be running on electricity, assuming you plug it in and charge it every day. And so your mileage will stay in that 250 range. If you have a longer commute of, say, 60 or 70 miles a day, then what you'll do is run the first 35, 40 miles on electricity, then the engine will start, and depending on how far you go beyond the electric range, then it'll start using more and more gas.
As far as there's the pedestrian warning, we were talking about it being quiet.
Right.
The vehicle's quiet, so how do you warn pedestrians that you're coming?
When the car's in drive, if you pull back on the turn signal stock, you should get a little chirp. Yep. Just like that.
Are there additional? We've got the climate control if we wanted to turn that on. We have the radio, stereo system, navigation.
Standard navigation system. Standard on every Volt. We also have standard heated seats, which might seem like a luxury feature, but it's actually something that helps improve the efficiency of the vehicle, because by heating your body directly through the seat, it doesn't necessarily have to generate as much heat through the vents.
Through the vents, exactly. And whereas normally an engine would create heat,
right?
This electric engine does not create as much heat, right?
Yeah. The electric engine itself, the electric motor doesn't produce any heat. When the engine's not running, the only source of heat is going to be the battery itself.
Got it.
You got it. There's an electric heater and an electric air conditioning system built in. There's also an eco mode for the climate control, so that you have a standard climate control system where you can set the temperature. The eco mode will allow the temperature to vary a little bit more than it normally would, so it's more efficient.
Back into park and just off.
That's it.
Phew. I like how it has a sound that lets you power down.
So this tells you went 2.7 miles on this charge so far. 2.7 miles total, no gas used, and the lifetime mileage of this car since it was built is 47 miles per gallon.
Neat. Thank you very much.
My pleasure.
This has been a lot of fun. But if I were to have used all the electricity in this car, out of gas, out of battery power, what would I do? When we come back, we're going to talk with some people at GE about how GE is innovating electrical infrastructure. This episode is brought to you by Squarespace.com, the fast and easy way to publish a high-quality website or blog. Squarespace.com makes it easy for you to use with their UI for creating and managing a website or blog. It's optimized for both beginners and CSS experts. Build it, host it, and update it anytime For a free trial, go to squarespace.com. Sign up for a free account. Then, if you decide to purchase it, use the offer code GREENTECH and get 10% off the lifetime of your new account. That's squarespace.com and use the offer code GREENTECH.
There are gas pumps all over this country, but not many places to plug in an electric vehicle. I'm speaking with Britta Gross. She is the Director of Advanced Technology Government Business Development Infrastructure, basically, and she's working to help make electric adoption easier. Britta, can you tell me what GM is doing specifically to advance electric vehicle adoption?
When you look at it from an infrastructure charging perspective, our priority is definitely on the home. Get home charging installed, give everyone a single, reliable, safe, convenient place to charge each day. If you don't have the convenience and the reliability and safety to charge your vehicle at home every day, our second priority becomes workplace charging, because if you're not parked at home, chances are you are definitely parked at work for extended periods of time. And then the rest of it, this infrastructure in public and so on, is something that's sort of nice to have. It's nice for education, awareness, and outreach, but the Volt, of course, is not designed to need a lot of infrastructure. It is designed to be charged once a day, basically at home.
Right, so let's take a look at the charging station. This is one of the higher voltage charging stations. Can you tell me a little bit about what goes into getting this installed?
Absolutely. This is the 240 volt Voltec unit. Charges the Volt in about 4 hours, as opposed to just finding a three-pronged outlet in your garage or on your in your driveway or in your carport, where you plug into the three-pronged 120 volt socket and it charges in about 10 hours. So it does cut down the charge time, but 10 hours, 4 hours, both very, very convenient, I would think, for home charging. And so what you see in here, it's just simply a 240 volt mounted unit. Electrical code in the United States requires this thing to be wall mounted. GM worked real hard with the industry to come up with this industry standard adapter through the Society of Automotive Engineers, and it's called the famous J1772 connector.
Very famous.
If you say
everybody
that,
knows.
Everybody knows you're an expert when you say that.
Okay.
And you simply plug this part into the vehicle, and away you go, and charge the vehicle. So we have a whole partner. SPX is our partner for home charging installations, and when you purchase a Volt, you'll be contacted you'll be put in contact with SPX, and they'll help you sort out what are your options for home charging. Are you interested in 120, or is it 240, the faster charge? What does it take in your home? Do you have a really old home? Do you have a newer home? And we'll even link in the utilities if that's needed to answer customers' questions about charging rates and whatever else might have to happen in the home.
Right, so you've also got partnerships with the utilities that you're developing. What's going on there?
We started about 3.5 years ago and realized we had to have a very, very robust, deep dialogue with utilities, because not only do we want to start selling these vehicles, 10,000 this year, 45,000 next year, but our ambition is really to get this into the mainstream. And if you start imagining millions and millions of vehicles on the grid, you have to consider sort of the local utility issues and the aggregate larger issues on the grid. And we were convinced there's not an issue. In fact, the Volt charges really at a very nominal, minimal level, almost looks like any other appliance in the home. But it was important to have that dialogue with a very broad set of utilities, all the California utilities, many of the largest, most progressive, thought-leading utilities in the country, about 50 now, are our partners. And through that dialogue, we've made actually the Volt smarter than it would have been if we hadn't had this very good dialogue, and we're very well prepared for even the Generation 2 and Generation 3 improvements on the Volt, knowing where the technology can take this.
Right, so talking about the use and the energy use during certain hours, peak hours, off-peak hours, were those concerns of the utilities as you started going into conversations with them?
Yeah, I think that that's a really good observation. When you look at charging vehicles and look at most of the energy use during the year, there's really almost not an issue charging electric vehicles. They look like a lot of other appliances in your home, so it's a non-issue. So when we really talk about, gee, it would be great to be charging off-peak and so on, we're talking about a handful of days that do stress the grid. On those really hot August afternoons, muggy afternoon, it's getting really hot and muggy, all the air conditioners at homes are on, all the air conditioners at work are on, and you start to tax the grid. There's a lot of capacity any other day of the year, and any time of day, the other days of the year, but On those limited days, we actually do want to be smarter, and we can be smarter. The vehicle is a very, very smart appliance on wheels, and we have the ability to think through how could you steer the charging of vehicles into the early morning hours or away from evening or daytime or afternoon charging. So yeah, that was definitely part of the dialogue, is how do we design for actually the worst cases, not just the best cases, but the worst cases on the grid. And that gives us confidence that we actually can deploy millions and millions of these vehicles and not impact the grid.
Okay, so let's talk briefly about actually energy production. This is moving the energy production from the gasoline engine in a car. I mean, there is a gasoline engine in these, but moving more to electric production at, say, a coal-burning power plant somewhere. Can we talk about wheel-to-well energy use? And
sure. Okay, sure. Yeah, so Welding Wheels is the perspective we apply in the analysis we apply when we look at the whole the energy and environmental picture of vehicles and transportation. We call it Welding Wheels because it came from the old oil days. You imagine the well, you're digging the oil out of the ground through a well, pumping it out, and then you've got the wheels of the car. So you're taking that oil out of the well and you're moving it through the pipelines, and you're getting it over to fueling stations to fuel in a vehicle, and then you've got the experience on the vehicle with the tailpipe emissions and so on. It's called a Welding Wheels analysis. But it doesn't matter what the vehicle runs on, you can do a well-to-wheels analysis. So if it's energy production from a mixture of natural gas, coal, nuclear, wind, and solar, for example, the grid today, and hydropower, if you do that analysis, that becomes then the wheel part of this. How do you produce electricity, and what does that look like? And then as you move electricity through the grid into the vehicle and you're driving off electricity or in the extended range off of gasoline, what does that sort of energy picture look like? And the picture looks really good for electric vehicles. When you're driving on electricity, of course, you've got zero tailpipe emissions. And even when you're considering the way electricity is produced, even if you're considering coal and natural gas and other carbon fuels, still the picture compared to a conventional gasoline vehicle is still better. And the really important thing to keep in mind is that electricity is getting cleaner and cleaner and cleaner. We have the ability to actually affect that, and gasoline is not going to get cleaner and cleaner and cleaner. And so here we have this opportunity to really significantly improve the vehicle itself and the grid itself with huge positive outlook for the future.
Is GM involved at all at sustainable grid development in terms of actually affecting major electrical grid infrastructure?
I think maybe you're referring to smart grid?
Yes.
Okay, smart grid, absolutely. And what's really brilliant about this moment in time is that the smart grid was just starting out. And so although there's been some implementation of some elements and aspects of smart grid, it was pretty much a blank piece of paper. And of course transportation was completely a blank piece of paper. What could we do with electrified vehicles? And so we had two roughly blank pieces of paper, and this relationship with the 50 utilities that we have and EPRI, the Electric Power Research Institute, this relationship has helped us understand what are the possible points in the middle where we can actually help each other. How can we design more smart features into vehicles, like delaying the start of charge on a vehicle? Or how do we communicate one day between utilities directly to the vehicle, like, hey, tonight we expect a lot of wind coming in, rates are going to go down, do you want to take advantage of this? Oh, yes we do.
Yes please.
So, yes, please. So that dialogue and what it means to help also shape the smart grid has been extremely valuable, and will just continue to improve and the relationship as we go forward, and make the smart grid smarter and the smart vehicle smarter as well.
How far do you think we are from a sustainable energy vehicle future?
I think if you really want to talk sustainability, you have to look not only at the wonderful Chevy Volt and what you can do with plugs. I think you also have to think about the space of vehicles today. And you think about larger vehicles, load-bearing vehicles, pickups and SUVs and crossovers and stuff. Those people buy those vehicles because there's a reason. They either have large families, or they use them for work and they're hauling plumbing equipment or wiring and stuff. That need is probably going to be difficult to fill with a plug-in vehicle. That one is better addressed by hydrogen fuel cells. Long range, quick refuel time, zero emission out the tailpipe, of course. And then you also combine this with also the solution space that involves biofuels. And when you look then at what biofuels can do to displace petroleum, most people don't know we've already displaced in this country about 5% of the gasoline we normally would have pumped into our vehicles, just because of the blending and the E85 we're doing with ethanol. Huge, huge, important thing for people to understand relative to energy security in the country.
Yeah, and there's still room for growth there.
And there's room for growth.
Yeah.
So between biofuels plug-in electric vehicles and hydrogen fuel cell electric vehicles. That space, now you're starting to talk about a sustainable future for transportation and energy fuels.
Okay. And what can we do to get there faster? What's GM doing?
We have a commitment to put E85 into, by next year, 50% of every vehicle, all the vehicles we produce will be E85 capable. That's number one. Make them capable of running on E85 as often as you can find E85 to fuel in your vehicles. Number two, the Volt, the Chevy Volt. Make it as compelling to the mainstream as possible. Not a niche vehicle, not early adopters and then it stops. This has got to penetrate the mainstream. And then significant investment and attention to hydrogen fuel cells. We have a whole portfolio of technologies that are going into these vehicles, and it's just relentlessly pushing the technology, leaping forward as much as we can, but never losing focus on what exactly is going to help transition our vehicles to something much more sustainable.
Great. Thank you very much.
You're welcome. Thank you.
Appreciate it. That was a lot of fun. I really enjoyed my test drive. This is a great small car that handles really well, has a lot of power. It's electric. What more can you ask for? Regardless of your opinion on the cost effectiveness of the Chevy Volt, just remember this car has a lot of potential as long as it stays current and overcomes the resistance. Thanks to that little pun from our bidding on Twitter. I really appreciate those little jokes. And for anyone else out there who's interested in looking to find out if the Chevy Volts are available in their area, go to getmyvolt.com and you'll find out more yourself. I'm Dr. Kiki and I am done green hunting for this week. Thanks for watching and stay tuned until next time.
That's it for this episode of Green Tech Today. Subscribe at twit.tv/GTT and never miss a show. If you have a question or a comment, email us at greentechtoday@twit.tv. Or you can leave a voicemail at 415-GT-TODAY.
I just locked the keys in the car. they're in there. In the cup. There's the cup. It's not on. It's not on. It's not locked and on. It's just locked. Right. I saw that in an episode of Modern Family. Yes. When they locked their child in a car and then they had to OnStar it.
Film this now. Oh, you get beat for that, huh?
It's gonna go.
That's a great show, by the way. Now he's flustered.
I don't want to be on camera.
Where's
OnStar. Because it's OnStar, we can get the VIN number or the license plate number and have them unlock it remotely. It's great when you're, in an urban area where there is satellite coverage.
Yeah, we have it right.
This is going to be an extra special episode.
Extra special, yeah. I had a feeling we were coming down here. I was like, right there. This is going to be something. You sound so evil when you do that.
I did it! Now we have somebody else they're calling. They're going to call it, but they're going to talk to the OnStar people. Unlock it remotely. This is always very good. If this works, this is seriously one of the pinnacles of technology, the ability to get you into your car that you've locked yourself out of without you having to get one of those little Slim Jims or call AAA. It's just easier. Hello? I locked myself out of my car. Can you help? I think they lost the OnStar number.
Just 29 minutes in traffic, 14 miles. Okay, so we got it. Are you rescuing us? Yes. Oh,
Yay.
we're going to film it.
It was me. I did it.
Here comes
Okay. we get to see it actually happen.
So, are you calling OnStar?
Yes. We're calling OnStar right now.
To unlock your doors, press 1. Roadside assistance. If you have a personal pet locked in the vehicle, press 1. If not,
so go ahead and press 1.
Press pound.
Star Emergency, this is Deborah.
Hi, Deborah. I locked myself out of the car.
Unfortunate situation. May I have your home phone number starting with the area code first?
My home phone number or this one number?
You know what, this car is...
The phone number that's on the account.
Oh, yeah. This car is actually on the Pete Lewis account. Can I give you the last 4 of the VIN?
I need the whole VIN.
Okay, I'll give you the whole VIN.
Okay.
1G1, RD6, E42, BU1, 1423. 9. Thank you.
2011 Volt?
Yes.
Okay, and what's the name on the account?
Pete Lewis. It's a GM Fleet Media vehicle. And the
Go ahead.
And the password is 1234.
Okay, when was the last time the vehicle was running?
Just a few minutes ago. 15 minutes ago, maybe.
Okay, and a number just in case you and I are disconnected?
562-318-6156.
Give me the pin.
Okay.
Yes.
Not pull on the door handle, so you'll just hold the line with me for a minute, please.
Hold on the line.
I am still waiting. So 2011. It is unlocked. Go ahead and check the driver's door.
And it's open, like magic.
Okay. Well, thank you, and please know that we're here when you need us. You have a wonderful evening.
Thank you. You too.
Bye. Goodbye.
That was so
Faster than AAA.
much faster than AAA.
You don't need a coat hanger either.
I know. You don't scratch the car. Thank you.
Is that normally with all new GM cars, you get 1 year of OnStar service included.
Does somebody want these?
Because there's so many other features that rely on OnStar, including the smartphone app that we looked at earlier. We're including 5 years of OnStar service when you buy a Volt. So for the first 5 years, you don't have to pay anything extra for OnStar.
That's pretty cool. That's value.
It is.
Security.
Value, security,
Safety.
safety.
Exactly. Okay, it's unlocked. I can shut the door. Okay. Hands off the car. Just walk away from the vehicle.
Did OnStar unlock it?
Yeah.
There you go.
Perfect. It was great. We had an OnStar demo. Perfect.
So Suzanne's ready to go.
Where I think.
Yeah.
Okay.
Yeah, they've torn down all inside, so.